Hi, my name is Ihab. I'm the founder of the Airball Project and a lifelong aviation fan. And I'm making this video along with Melissa, who's behind the camera right now,
Hello.
um, to help explain to people how airplanes fly in a really simple way, and eventually to get to the point of talking about the Airball Project, why I created it, and what it's expecting to do.
Okay, so as someone who's not really engineering techie person, how do airplanes fly?
Well, so in general, if you ask people this question, there are two main groups of folks. And then there are others, but they fall into two main groups. Group number one is people who don't really know and probably don't really care, and that's fine, right? For example, I don't really know very much chemistry. Um, Group number two is people who believe that there's something about the air pressures. There's something about the length of time that a little bit of air travels over the top of a wing or the bottom of a wing. People who believe that it's related to this thing called Bernoulli's principle, but it's kind of a foggy thing. And in general, people have all these really complicated explanations swimming around in their minds. Very few, I think, have been exposed to a really simple, easy way to talk about that.
So that's your goal.
My goal is to try and get people to grok that easy way.
And why is that your goal?
Well, because I think it helps it's more fun, for one thing, right? It's fun to understand things and to feel the sense of relief when you know it. But it's also important for helping to understand how airplanes behave, and that helps us, I think, be better pilots. I am a pilot, and to me, this information makes it easier for me to do a better job.
Okay.
So let's step right to it. The process of flying or staying up in a fluid, it's the same for any kind of fluid. Whether a fluid is either a liquid or a gas. It's something that when you pour it into a container, it stays in the container and stays in the shape of the container. The staying up in a fluid is the same regardless of what the fluid is. There are only really two ways to do it, and these two ways are both things that you have done in a swimming pool, right? So the first way is to float. So let's talk about floating for a while. Here I am in a swimming pool, and oh no, I'm sinking, right? So here I am down here. What I can do is I can arrange to surround myself with enough material such that the space that I and that material occupy is large enough compared to the weight inside of it, such that it is lighter than the equivalent same space filled with water.
So in other words, you make yourself buoyant.
Exactly. I make myself buoyant by making myself big, but also light.
So you add water wings, or you inhale and you hold your breath.
Exactly. Right. Precisely. Water wings are simply a way for me to increase my size, but they're filled with air, right, which is relatively lightweight, and so the weight of all of this stuff inside of the boundary is way less than the weight of the water that would occupy that same space.
Uh-huh.
And so then the water pushes me up and I float. This is buoyancy. Now, there are aircraft that use the principle of buoyancy, and these are basically all the blimps and all the balloons and other similar so-called lighter-than-air aircraft. So a balloon can be filled with something that is super light, lighter than the air that surrounds it, which can be either a gas that you pick, like for example helium. Helium is very light. Or you can light a little fire down here, and that fire heats up the air, normal air inside of here. Now, air when heated up becomes lighter because the molecules of air move around more and space themselves out more from each other. And that then produces this buoyancy.
Okay.
So these are all lighter than air aircraft. There's a second way to stay up, and that is to tread water. So now, by treading water, I hang out near the surface of the water and I wiggle my arms in such a way that I stay up. What I'm actually doing really is I'm gathering water from around me and I'm hurling it down at sufficient speed that it keeps me up.
Okay.
There's not some magic happening here. The only thing that matters is Newton's laws. I'm pushing water down, a certain mass of water multiplied by a certain speed of how that water is coming down, and in return I'm getting a force upwards.
So which of Newton's laws is this?
Action and reaction.
Okay.
Another way I could do this, for example, is if I had a big fire hose. Excuse me. If I were somehow to attach myself to this big fire hose with a big nozzle.
So this is an unusually giant fire hose.
And unusually giant, but not too giant, because real fire hoses produce quite a huge force, right?
Mm-hmm.
So this fire hose shoots water down. If I attach myself to it and have this strong enough, it'll push me up. Another example is if you have a balloon, just a regular balloon filled with air, and you let go of it, and it goes bzzz and goes up.
Mm-hmm.
Another example is a rocket, right? A rocket basically contains some kind of fuel inside of it, and it sets fire to that, which comes shooting out the bottom with tremendous speed, and which pushes the rocket up. The difference between treading water and the rocket is the rocket has a whole bunch of stuff inside of it that it shoots down, and eventually it runs out of it. It can get a huge amount of force very quickly, but it's kind of finite. Here, by treading water, I don't have pieces of myself I can push downwards in order to get a lift up. But what I can do is I can make use of the stuff around me, gather it, and hurl it down.
Okay.
The equivalent aircraft that operates this way would be, for example, a helicopter. So if you imagine a helicopter, it's a little thingy with a rotor over here, and it's got this big egg beater up here. What it is doing is pulling air from above it and hurling it down at the ground with sufficient force that it keeps the helicopter up. This downward moving air is called downwash, right? And so a helicopter is just a machine for creating downwash. And that downwash produces a force upwards, which we call lift. It turns out all heavier than air aircraft are simply machines for generating downwash. Now that brings us to a question of fixed wing aircraft, or so-called airplanes. So observe this helicopter here. I know my drawing is simple, but real helicopters are extremely complicated. They have tons and tons of moving parts. What if, one would say, you can arrange to be of a particular shape such that as you go from one point to the other, because you're flying in order to get somewhere anyway, right? So as you go from point A to point B, that motion through the air somehow generates the downwash that you need, right? And we observe this with birds, right? Birds can sort of like hold their wings still and go over from one place to the other, and they float in the air, so they must be producing lift. So the way we do this, or really, if you will, the problem that we have posed ourselves is design a machine, right, that will go through the air, and as it goes through the air, it must somehow redirect the air downwards such that it produces downwash. It is a machine that makes downwash out of forward moving air. And how to do that is really the crux of this whole description we're going to have today. A machine such as this is the only thing that is properly referred to as an airplane or a fixed wing aircraft.